Good day, Puerto Princesa! Behind me is the historic Plaza Cuartel. Pre-pandemic, this is one of the most visited spots by both local and international tourists. Don't you know that this beautiful and serene view of this place was once a place of terror during World War II? Well, this place has witnessed cruelty beyond imagination. But now, it is a place where happy memories of every Palaweño is kept. Hello, grade 9 Dream learners! Welcome to Puerto Princesa Dream TV, your digital classroom. Come, let's get ready to be amazed and unlock aha moments with the grade 9 quarter 2 chemistry lessons. I am Teacher Anna, and I will be your virtual teacher as we explore the wonderful subatomic world. Aren't you excited? Well, I am. Have a pen and paper handy as we dissect the lesson carefully. At the end of the lesson, you are expected to utilize Bohr's atomic model in describing an electron's energy level with the help of the modern periodic table. Analyze a narrative to grasp the concept of locating probable electron inside an atom using the quantum mechanical model. Predict the electron's location or the electron configuration of some elements. To check what you already know about the lesson, let's try this activity. I will show you the question, and you are going to choose the letter of the correct answer from the given options. You are given 5 seconds to answer each question, and when you hear this, that means the time is up. Are you ready? Let's start! Directions. Listen and analyze the following questions and select the letter of the best answer. Write your answer on your paper. Number 1. Which atomic model was introduced by Erwin Schrödinger? A. The nuclear model. B. The planetary atomic model. C. The plum pudding atomic model. D. The quantum mechanical model. Number 2. What does azimuthal quantum number refer to? A. Orientation of the orbitals inside the atom. B. Shape of the atomic orbitals. C. Size and energy levels of the orbitals. D. Spin of the electron in its orbitals. Number 3. How many electrons can an f orbital carry? A. 2 electrons. B. 6 electrons. C. 10 electrons. And D. 14 electrons. Number 4. Which principle states that an atomic orbital contains two electrons of opposite spins? A. The Aufbau principle. B. The Hund's rule. C. The Pauli exclusion principle. And D. The uncertainty principle. Number 5. What refers to the electron specific address inside the atom? A. Atomic orbitals. B. Electron configuration. C. Electron orbits. And D. The nucleus. Check your answers on the screen. Number 1, D. Number 2, B. Number 3, D. Number 4, C. Number 5, B. Let's get to know the subatomic particles first, in order for us to really get a good grasp of the lesson. And with that, let me tell you a short story. Once upon a time, there lived three subatomic particles, namely electron, proton, and neutron. Proton and neutron lived in the nucleus of the atom while electron wandered around it through an electron orbit, sometimes near, sometimes far, and sometimes out of reach. Proton is nice but shy and of controlling attitude because of its optimistic view. Neutron with a neutral attitude doesn't care about anything and just stay in the nucleus with proton, while electron is the most energetic and the most stubborn, especially if it's far from the nucleus with an innate pessimistic outlook. Electron might be wild and full of energy, but let me tell you a little secret. It lights up as it loses its energy while it approaches the nucleus and slowly behaves as a tame subatomic particle, all because it gets attracted to proton. Did you like this story? It is actually the summary of how Niels Bohr described his atomic model using the hydrogen atom. Trivia. Do you wonder how a battery is able to light up a bulb? Notice a battery has positive and a negative terminals. Remember, electron is attracted to proton. That's why electron, a negatively charged particle, travels from one end of the battery and flows through a conductor because the other end of the terminal is attached to a proton-rich material. Electron carry energy. That is why, whenever it gets passed through a device, a bulb for example, the energy gets converted to light. Its energy is consumed without it being able to reach the other end of the terminal. The light would turn off if they detach the other end from the positive terminal that hinders it from flowing, which is being controlled by a switch. That was actually your lesson in grade 8. As you notice, of all the three subatomic particles, electron is the most active, especially if it dwells away from proton. Therefore, electron's location inside the atom is very important in determining how reactive an element is. Electrons that dwell in the outermost shell of an atom is called valence electrons. Valence electrons are the most active electrons given that their location is the farthest from the nucleus where the protons are located. They tend to be the most unstable ones with the highest energy levels, and to tame it down, it had to look for a pair to be stable. That's why elements react and form substances. That's how they attain stability and react with other elements. Therefore, electrons play a great role in the behavior of the elements. Let's deepen your understanding about the behavior of subatomic particles in relation to how atoms of elements behave. You will be needing the help of the periodic table of elements in understanding the lesson further. Let us use the elements under Group 1A to further understand Bohr's atomic model. That's lithium, sodium, potassium, and rubidium. The atomic number of an element represents the number of the electrons inside an atom. The period number determines the number of the orbits within the atom. The group number tells us how many valence electrons are found in the outermost shell or the valence shell. Let's compare the valence electrons' energy level of the elements under group 1A. Lithium has only 3 electrons. It's under period 2, so these electrons are accommodated in its 2 orbits. It is in group 1A, so that lone valence electron in the outer shell is the one responsible for bonding in lithium atoms. Looking at the atomic model of the rest of the elements, you can obviously tell which element is the most reactive. Just look for an element with the farthest valence electron from the nucleus. Can you tell which one? Yes, you are right. Rubidium. A flame test can attest on elements' energy levels. Check this out. Lithium glows red, while sodium glows yellow. Potassium with violet and rubidium glows violet to white flame. If you check the color temperature chart, you can tell that lithium has the lowest energy level, while rubidium is the strongest one. Why do scientists in dire search for electrons' location inside the atom? Take this comparison of an object on top of the table. Nothing would happen to it if there is no energy or force applied. According to the Newton's first law of motion, inertia, it will stay on top of the table forever unless a force is applied. Subatomic particles are in everything around you, whether you see it or not. And of the 3 subatomic particles, electron bears the energy. Therefore, it is the one that makes the difference. Niels Bohr's atomic theory is so useful in describing the behavior of the subatomic particles that opens up several scientific researches about the behavior of atoms. Later on, scientists found out that Bohr's atomic model is only limited to atoms with fewer number of electrons. This opens up scientific debates. One of those is Louis de Broglie's uncertainty principle. Erwin Schrödinger improved de Broglie's idea and paved the way for dealing subatomic particles known as quantum mechanics or wave mechanics that made him to describe the atom using his model named the quantum mechanical model, and his discovery that atoms behave both as a particle and a wave. Trivia. Knowing this concept of submicroscopic world of atom helped researchers and doctors understand about tumors and drugs. Modern technology has led its way in developing devices using ultrasound waves. When an address says San Juan Road, Barangay San Miguel, Puerto Princesa City, Philippines, it means that the location is along San Juan Road, under Barangay San Miguel, and in the city of Puerto Princesa in the country Philippines. Locating electrons' address inside the atom pretty much works the same. You just have to consider the following terms. The principal quantum number. The shell that indicates the size of the subshell and the energy level. The bigger its value, the higher the energy level. The azimuthal or angular quantum number. It defines the shape of the orbitals or region, also named as subshell. The value of L is designated as S, P, D, F, and so on, for sharp, principal, diffused, and fundamental, respectively. The magnetic quantum number. This quantum number describes the orientation of the orbitals in space. The spin quantum number. George Allenbeck and Samuel Goldsmith proposed that an electron spins in the axis as the Earth spins in its axis. There are two possibilities for electron spins: a value of positive 1/2, which is spinning counterclockwise, or negative 1/2, which is spinning clockwise. The spins are said to be paired. A spinning electron generates a magnetic field, but a pair of electrons with opposing spins has no magnetic field, which explains why atoms with unpaired valence electrons are more reactive than those that satisfy the octet rule, which are stable electrons. Let us further understand those terminology by using an analogy for you to simply understand electron configuration, or basically the process of scientists to use in locating probable electrons inside the atom.
My name is Quanta. I own a big apartment building. It is a 7-story building and is designed that it can be extended to several levels if there's a need for more spaces. It has 4 types of rooms: the S room, the P room, the D room, the F room. The S room is the smallest among the 4. It has only 1 bunk bed. The P room is a little bigger. It has 3 bunk beds and can be arranged in 3 ways. The D room has 5 bunk beds and that can be arranged in 5 ways. The biggest room is the F room. It has 7 unique bunk beds that are arranged in 7 different ways. Big rooms are only available on higher levels. Each type of room gets a unit bigger every level. During this COVID-19 pandemic, I would like to open it as a quarantine facility to cater stranded Filipinos. But I have 3 major accommodation rules that everyone strictly needs to follow. First, follow the Okbo principle. I have arranged the room accommodations in a certain pattern, with rooms in the lower levels and up, starting from the smallest to biggest room. Just follow the pattern below. Second, the poly-exclusion principle. There are bunk beds in every room. Each of the bunk beds can accommodate only at most 2 persons, 1 on the lower deck and 1 on the upper deck. And lastly, the Hans rule. If the very first person uses the lower deck, all of the succeeding rooms will have to follow the pattern. Occupy all the available lower decks first, before occupying the upper decks. On the other hand, if the very first person chooses the upper deck, then follow the pattern to occupy all the vacant upper decks before occupying the lower deck. Example: Room P has 3 bunk beds. If person number 1 chooses to occupy the upper deck, then person number 2 has to use the upper deck of bunk bed 2. Person number 3 shall occupy the upper deck of bunk bed 3, and then persons number 5, 6, and 7 can then occupy the remaining 3 lower decks of room P, respectively. Then, proceed to another room following the same guidelines. That's 3. I am very keen in catering people to be quarantined because of the dangers this pandemic brings. My quarantine protocol is to accept people 1 batch at a time regardless of the quantity. The rules given above is organized in order to easily track a person if ever someone contracts the virus.
You are given 5 seconds to answer each guide question.
Let's check what you have learned from the passage. Number 1. What does Quanta's building characterize? The Bohr's atomic model. The quantum mechanical model of atom. Number 2. What does each story or floor level represent in the quantum mechanical model? Principal quantum number, azimuthal quantum number, spin quantum number, magnetic quantum number. Number 3. What do the rooms represent with respect to the atomic model? Principal quantum number, azimuthal quantum number, spin quantum number, magnetic quantum number. Number 4. What about the bunk beds? Principal quantum number, azimuthal quantum number, spin quantum number, and magnetic quantum number. Number 5. What do the upper and lower decks imply in the model? Left and right electron spin, positive half and negative half spin. Number 6. What do the arrangement of the bunk beds signify? Principal quantum number, azimuthal quantum number, spin quantum number, magnetic quantum number. Now there are already batches lining up in the quarantine facility, fluorine cooled, and they will be the first batch to utilize my building. Number 7. How many electrons does fluorine have? Refer to the modern periodic table. 18, 15, 9, and 6. Number 8. Identify the exact location as to where the last electron would occupy. 3p6, 3p3, 2p2, 2p5. Let's check your answers. Number 1. The quantum mechanical model. Number 2. Principal quantum number. Number 3. Azimuthal quantum number. Number 4. Spin quantum number. Number 5. Positive and negative spin. Number 6. Magnetic quantum number. Number 7. 9 electrons. Number 8. 2p5. The quarantine facility analogy made it easier for you to understand electron configuration. Let's have one more practice to see if you really had grasped the idea of finding the probable location of electrons inside the atom. Predict the electron's location or the electron configuration of some elements.
Please scan the QR code flashed on your screen for the resources you will be needing in this episode.
The figure below is a table showing the electron configuration of the element sodium. Let E1 be electron 1 or first electron. Let E2 be electron 2 or second electron, and so on. The electron configuration of sodium is 1s2, 2s2, 2p6, 3s1. Write the electron configuration of the element aluminum. Please use the table flashed on your screen with the same format to show the Hund's rule.
You have 1 minute and 30 seconds to answer this activity.
Let's check your answers. If we take a look at the periodic table, aluminum's atomic number is 13. Therefore, there should be 13 electrons to locate. According to the off-bulk principle, electrons start filling the orbitals from lowest to highest, starting with 1s1 as the lowest level. Each orbital carries 2 electrons according to the Pauli exclusion principle. And lastly, the Hund's rule. The 2 electrons in an orbital has 2 opposite spins. If an orbital contains 2 or more subshells, the electrons of the same spin has to fill in the orbital first, followed by the ones of the opposite spins. So for aluminum, electron 1 on E1, electron 2 on E2, then move to the next energy level, 2s2, electron 3 on E3, and electron 4 on E4. Now entering 2p6 with 3 subshells, a larger orbital. Let's follow the Hund's rule. Electrons 5, 6, 7 has to enter first, followed by the 3 succeeding opposites, electrons 8, 9, and 10. 3 more electrons to fill. Let's enter 3s2 orbital with only 1 subshell. Electron 11 and 12 are catered. Since we have 1 more electron left to be catered inside 3p6 orbital, in this case, it will only occupy up to 3p1. Let's copy all the orbitals occupied by the 13 electrons of aluminum. We have 1s2, 2s2, 2p6, 3s2, 3p1. Trivia: sodium belongs to group 1A. That means, of all its 11 electrons, that single valence electron located in 3s1 is the one responsible for bonding with a chlorine ion to make up a compound named sodium chloride, or commonly known as table salt. It is such a complicated process, but it makes really good sense because by learning this topic, we can somehow understand why certain things behave the way it should. Want more? Let's have it as your assignment. But first, let's summarize the important points in this lesson. Of all the three subatomic particles, electron is the one that made a difference in every atomic behavior. As the electron gets nearer to the nucleus, it reduces its energy. Electrons that are found in the outer orbits of the atom are called the valence electrons. Of all the electrons inside an atom, they're considered to be the farthest from the nucleus, therefore considered to be the strongest. The above knowledge is explained in the Bohr's atomic theory. According to Louis de Broglie, electrons possess a wave property. They vibrate and move constantly. That is why we cannot use the Bohr's atomic theory in describing atoms with higher number of electrons. This is described by Heisenberg's uncertainty principle that leads to the development of a new atomic model, the quantum mechanical model. In the quantum mechanical model of atom, there are four quantum numbers that best describe the specific location of the electrons inside the atom. The principal quantum number indicates the size of the subshell and the energy level. The azimuthal quantum number, on the other hand, determines the shape of the orbital, region, or subshell. The magnetic quantum number describes the orientation of the orbitals in space. There are three rules to follow in determining the electron configuration of an atom: the Aufbau principle, the Pauli exclusion principle, and the Hund's rule. The Aufbau principle states that an orbit caters to at most electron, while the Pauli exclusion principle states that those electrons have also two different spins. And the last one, the Hund's rule, it states that if the very first electron of an element occupies the positive spin, all of the electrons has to occupy the same type of spin before filling up the opposite spin in every energy level. Example, 1s2, 2s2, 2p6, etc., where the exponents signifies the number of electrons in that orbital. Directions. Listen and analyze the following questions and select the letter of the best answer. Write your answer on your paper. Number 1. Which atomic model was introduced by Erwin Schrödinger? A. The nuclear model. B. The planetary atomic model. C. The plum pudding atomic model. D. The quantum mechanical model. Number 2. What does azimuthal quantum number refer to? A. Orientation of the orbitals inside the atom. B. Shape of the atomic orbitals. C. Size and energy levels of the orbitals. D. Spin of the electron in an atomic orbitals. Number 3. How many electrons can an f orbital carry? A. 2 electrons. B. 6 electrons. C. 10 electrons. And D. 14 electrons. Number 4. Which principle states that an atomic orbital contains two electrons of opposite spins? A. The Aufbau principle. B. The Hund's rule. C. The Pauli exclusion principle. And D. The uncertainty principle.
Number 5. What refers to the electron's specific address inside the atom? A. Atomic orbitals. B. Electron configuration. C. Electron orbits. And D. The nucleus. Check your answers on the screen. Number 1, D. Number 2, B. Number 3, D. Number 4, C. Number 5, B. Before we end this lesson, I want you to practice more at home. For your assignment, write the electron configurations of potassium, magnesium, and oxygen. Please use the same format on the table that we provided. Write this in a one whole sheet of paper and submit it to your science teacher.
Congratulations, Dream Learners, for completing this episode. We have unlocked another science lesson that you can apply in your daily lives. Another lesson in your head, making yourself better than yesterday. Just remember, dreamers, in this pandemic time, the best person to compete with is your older self. Stop comparing yourself from others and aim to be one step better than yesterday every day. Keep discovering and continue learning. For our next episode, we will discuss more of the subatomic particles, which tackles how elements bond. This has been your virtual teacher, Anna. See you again in the next episode of Puerto Princesa Dream TV.